My name is Muhammad Shahid Mazlan, number metric F1046. And you?
My name is Latif Faham bin Fairuz. My metric number is F1059.
My name Muhammad Saifullah bin Muhammad Sabri. My number metric F1061.
My name is Muhammad Syabul Amin Muhammad Rashid. My metric number is F1041.
Okay, today I will discussing an important application of diffraction in civil engineering. Beam deflection analysis. When designing building, bridge or any structure that involves beam, engineer must ensure that the beam can withstand loads without bending excessively. By using diffraction, we can calculate and predict how a beam will deflect under different force, ensuring the structure remains safe and stable.
Okay, for the scenario, what about we take a civil engineering? Because in civil engineering, beams are essential component of building, bridge and other structure. When a beam carries a load, it bends slightly due to the applied force. If the deflection is too large, the structure may fail or become unsafe. Engineers use differentiation to determine the shape of the beam under load and calculate the maximum deflection. The relation between the bending moment M and the beam deflection is given by M L fret d power 2y dx power 2 is the modulus of elasticity. Material stiffness is the second moment of error. Beam shape factor is the beam deflection and is the best position along the beam. By differentiating the bending moment equation, engineer can determine the curvature, slope and deflection of the beam at any point. The information is crucial when designing beam to meet safety regulation and engineering standard. For example, in bridge construction, engineer must calculate how much a bridge will deflect under the weight of vehicle. If the deflection exceeds the allowable limit, they must adjust the beam size, material or support system.
Number 2, objective. Predicting structural behavior. Using differentiation, engineers can analyze how beams will react under different loads. The first directive gives the slope of the beam, while the second directive provides the curvature, helping engineers visualize the beam shape under stress. By understanding these values, engineers can determine where the beam experiences the most stress and reinforce it accordingly. Number 2, optimizing beam design. Engineers use differentiation to minimize deflection while keeping costs low. Next, optimizing beam design. Engineers use differentiation to minimize deflection while keeping costs low. If a beam bends too much, engineers can modify its thickness, material, or length to improve performance. This is crucial in large-scale projects like skyscrapers, bridge, and stadium, where minor deflection can cause major safety concerns. And lastly, ensuring safety and compliance. Building codes and regulation specific maximum allowable deflection for different structures. Engineers must use differentiation to ensure that their beam design meet this standard before construction begins. By applying mathematical models, they can predict potential failures and take preventive measures before real-world testing.
In conclusion, diffraction is a fundamental tool in civil engineering, particularly in beam deflection analysis. By using diffraction, engineer can predict how beam will react under various loads, optimize beam design for efficiency and cost effective, and ensure the safety and stability of structure by following engineering standard. Without differentiation, engineering would struggle to design structure that are both strong and economical. Understanding how beam bend under stress is key to constructing safe bridge, building and infrastructure that last for decades. Thank you for listening.